Assalamu alaikum dear students, how are you? Boys, if we look the daily life, you will see that there are a lot of examples of energy transfer. So here in these practice questions, we will solve questions that are related to conservation of energy and the transfer of energy and also something about the efficiency. Okay. So first of all, just I will give you one example. For example, you are running. Okay. So when a runner run, what forms of energy changes? Okay. At the start, when you have just at the start you are standing, the runner's muscles are the storage of chemical energy. Okay. In their muscles, what type of energy is stored? Chemical. As he start to move, this chemical energy transfer to what thing? He move. The energy that is related to movement is called kinetic energy. So there are many examples. For example, another example we consider switching on the light. So what is the energy we give as the input? Electrical energy. Then it change into what forms? Output of the light is lamp, thermal, and light. Thermal is dissipated energy, wasted energy, and the light is useful energy. Now let's solve the questions here. For example, if you look here, question number 10. The diagram represents the energy transfer for a device. For any device, it's showing like that, okay? I hope you can see it. This is called Sinky diagram. The width of this arrow, okay, this is proportional to the energy. So look that here. This device, the straight line going, it shows useful energy, and the line, the arrow that is going down, it shows wasted energy, okay? So the device is 50% efficient. What do I mean by 50% efficient? It means that half of the energy is wasted and half of the energy is useful, equal. This is the mean by 50%. So the device is 50% efficient. What equation is correct? So where it is written that wasted output and the useful output are equal, because 50% mean half of. Okay, so it means that both portions are equal. This is your correct choice. In the same way, if you look on question number 11 here, the diagram shows the energy transferred in a lamp in 1 second. I told you already, there is energy transferred in the lamp. Here 100 joule is electrical energy. It changes, output is light energy that is useful, and the wasted is in the form of heat. So I answer already this question. Which type of wasted energy is produced by the lamp? Which type? What is the wasted energy form? This is thermal energy. Okay, this is your correct answer. In the same way, if you look here, question number 12, a ball of mass 1.2 kg is dropped from a height of 30 meters. This ball is at the height. Whenever any object is at the height, what energy it contains? What energy it stores? Potential energy, gravitational potential energy, okay? As it falls, 25% of its initial gravitational potential energy is transferred to thermal energy. So whatever the potential energy it has here at this height, we can find using MGH equations. This one. All things you have M, mass, height you have 30 meter, value of G is 10 Newton per kg, or free fall acceleration is 10 meter per second square, okay? So whenever you will calculate it, its total potential energy at this height using this equation will be 360 joule, okay? He said that 25% of the initial gravitational potential energy is transferred to thermal, 25% is wasted. So 25% of 360 will be 90 joule. 25% mean how much energy is wasted? 90 joule is wasted. Total input was 360, 90 joule is wasted. What left? That will be the useful 360 joule minus 90. So whenever you will subtract it, your answer will be 270 joule. That is the useful energy, okay? So in this way you will solve it. If you look here, number 13, read it. Some processes are more efficient than others. Which expression gives the efficiency of the process? Efficiency equal to what thing? Total energy output? No. In the efficiency we consider only the useful energy output. So what is the useful energy output? Overall total multiplied by 100. So A cannot be option. B is the option for us. Okay. Okay, in the same way here, if you look on question number 14, a lamp has a power input of 5 watt. This is the total input 5 watt. It wastes 1 watt. So what is the useful energy? Look, total you gave 5, wasted 1. So the useful energy is, useful power is 4 watt. And what is the total you have? 5 watt. So how you will find its efficiency? Just multiply by 100%. Okay, after simplification you will get it. C, 80% energy is useful and 20% is wasted. Okay, in the same way, if you look on the question number 15 here, a 40 watt lamp wastes 34 of energy every second by heating its surrounding. What is the efficiency of the lamp? In the same way, look here, 34 energy is wasted. So what is useful energy? Only 6 watt. 34 joule each second mean 6 watt. 34 watt is wasted, so 6 watt left. And what is your total input? 40 watt. Okay, so multiply by 100%. What will be your answer? 15%. That will be its efficiency. So you will solve these questions like that. Now we'll go to the page number 2 here. Let's see here another question. Can you see it clearly or no? Or I make it more big? Okay, I thought this is okay. Okay, the figure below shows a rock. Can you see this rock? It's falling. That is falling the top of the cliff into the river below. Here is a river. It's falling from here. So whenever it will be at the top here, what energy it will have? It will have gravitational potential energy it will contain in it. Okay. The mass of the rock is 75 kg. The acceleration of the free fall is 10 meter per second. I am reading the A part. Calculate the weight of the rock. Look, mass is given to you. How you will find the weight? Weight equal to what thing? M times G. What is M? M mean here mass of the object. Okay. What does it mean by M? Mass of that object. This is mean by M. Okay. So if we solve it, just substitute the value in this equation. So what is M here? 75 kg. And the acceleration is 10. So 75 kg multiply by 10 meter. This is the free fall acceleration. Okay. So what you will get? 750 Newton. Okay, this is the weight. Okay, second part, if you look, the rock falls from the rest to a distance of 15 meter before it hits the water. So what is its height that it falls? This height is at 15 meter. Okay, whenever it is at the height, what energy it has? GP, gravitational potential energy. So whenever it will fall, before hitting the river, it is moving. Here all this potential will change into what forms? Kinetic energy. This is a transfer of energy. But total amount of energy will remain the same according to law of conservation of energy. So we can write here this thing, that kinetic energy at the bottom is equal to G gravitational potential energy at the top. Both values are the same. That kinetic energy at the bottom when it reach is equal to gravitational potential energy at the top. So how you will find the gravitational potential energy? Easily you can find it, mgh. Same will be the kinetic energy, because here in this question we have to find the kinetic energy, calculate the kinetic. If you calculate potential, it is equal to kinetic. Okay, substitute the value. What is the M here? 75 kg. G value is 10. What is height? 15. So simply multiply them. 75 multiply by 10 multiply by 15. Okay, when you multiply it, your answer will be 11,250 joule. 11,250 joule. So in this way you are able, joule you know is the unit of, joule is the unit of what thing? Kinetic energy. Any energy like kinetic energy, potential energy, chemical energy is the unit of, joule is the unit of. So just to make it more clear, so here again if you take our pen, it's here. Okay, so 75 multiplied by 10, the value of g free fall acceleration, right? Unit with it, it's better. Okay, so 75 kg, then 10 meter per second square. It's better to write quantity is always with the unit. Okay, then multiply with the height. What is the height? 15 meter. Okay, so if you multiply all these numbers, your answer will be 11,250 joule. So boys, in this way, first it's very important to understand the question, because if we not understand the question, how we can solve it? Impossible. The rock hits the water. Okay, whenever it hit the water, what happened to the kinetic energy? Before hitting the water, it has kinetic energy 11,250. When it hit the water, where does energy go? What energy changes come? So what do you think? First of all, whenever it will hit the water, what you will listen? I hope you will listen the sound. So you can write this thing, sound energy of splash. This is one of the change. Sound energy of splash. Okay, on impact with the water. Okay, second thing maybe there is thermal energy. Okay, as it will hit the water and rock, thermal energy also changes. Some of the energy changes into thermal. Third thing, look that whenever that rock will fall in the water, waves will produce or no? So some energy will be used to produce these waves. So kinetic energy of the moved water. Okay, as the water moves or makes waves, so some energy will transfer to that form. Okay. So these are the transfer of energy, or you know that it produces some waves. When the rock will fall in the water, definitely waves will produce. So the kinetic energy will be used for these processes. Okay, thank you so much. I hope this is clear to you. So practice questions are very important. Okay, please revise them again. It's very important.